Hello everyone, I am Jefferson Bancairen. So in this section, I am going to discuss to you more discrete probability distribution. So specifically, I am going to discuss to you geometric distribution and the Poisson distribution. So we'll start with geometric distribution. So a geometric distribution is the distribution of the number of trials needed to get the first success on repeated Bernoulli trials. So, a situation is said to be geometric setting if the following four conditions are met. So, the first condition is a trial is repeated until a success occurs. Second is the repeated trials are independent of each other. Third one is the probability of success P is constant for each trial. And lastly, the random variable x represents the number of the trials in which the first success occurs. And also, a geometric distribution is a discrete probability distribution, right? So, the probability that the first success will occur on trial x is P of x is equals to P times Q raised to the power of x minus 1, where Q is equals to 1 minus P. So P of x here is the probability of the first success will occur on the nth trial, while P of success is the probability of success, which is equals to P, and this stays constant for trial to trial, while Q is the probability of failure, where it is the complement of the success, which is equals to 1 minus P, since it is complement of success, and X represents the numbers of trials needed to get the first success. Number of trials needed to get the first success. To make it clear, I will give you an example.
Five minutes later.
Okay. So using the geometric distribution, we will going to answer this problem. A study found that the smartphones made by a certain manufacturer had a failure rate of 43%. 4 smartphones made by these manufacturers are selected at random. Find the probability that the 4th smartphone is the first one to have a failure. So, our solution here is our probability of success is 43%. So, P is equals to 43%. But we don't want percent in our solution. So, instead of 43%, we will divide it by 100%. So, we get 0.43, right? So, and our Q, we know that our Q is 1 minus P. Therefore, 1 minus 0.43 is equals to 0.57. X is 4. So, using the formula of the geometric distribution where P of x is equals to P times Q raised to the power of x minus 1, we get P is 0.43. Then our Q is 0.57 raised to the power of x minus 1, where x is equals to 4. Therefore, 4 minus 1, so 0.43 times 0.57 raised to the power of 3, which is equated as 0.080. So the probability that the 4th smartphones is the first one to have a failure is about 0.080. Since we already learned about the geometric distributions, now we are going to proceed another set of distribution, which is the Poisson distribution. So, a Poisson distribution is a probability distribution that can be used to show how many times an event is likely to occur within a specified period of time. So, in other words, Poisson distribution is also called count distribution. Okay? A situation is said to be a Poisson setting if the following three conditions are met. So the first condition is the experiment consists of counting the number of times an event X occurs in a given interval. The interval can be an interval of time, area, or volume. Second is the probability of the event occurring is the same for each interval. And lastly, the number of occurrences in one interval is independent of the number of occurrences in the other interval. So, the probability of exactly X occurrences in an interval in the Poisson distribution is P of X is equals to mu raised to the power of X times E raised to the power of negative mu over X factorial. So, mu is the average number of times that an event occur in a certain period of time or space. E is estimated as 2.71828 and X here is the variable that we are finding for its probability. So it is the number of occurrences. Number of occurrences for success. So in getting our mu is equals to N times P, where N is equal to the number of samples and P is the probability of success. I will give you an example. So the problem goes like this. The mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month 4 accidents will occur at this intersection? So it is clearly that our mean here is 3, which represented as mu. And our X here is 4, since it is 4 accidents will occur at these intersections. So by substituting from the given formula, we get P of 4 is equals to raised to the power of 4 times 2.71828 raised to the power of negative 3, since it is negative mu, and then over 4 factorial or X factorial. So if we plug it in our calculator, so 3 to the power of 4 times 2.71828 raised to the power of negative 3 divide 4 factorial, we get estimated of 0.168. And now, we are clear with the formula of the Poisson probability distribution. So now, we will going to find the probability of the Poisson distribution using a table. So, we say example, a population account shows that the average number of rabbits per acre living in a field is 3.6. use a table to find the probability that 7 rabbits are found on any given acre of the field. We see from this table, mu is equals to 3.6 and x is equal to 7. So their intersections is, or using the distribution for mu is 3.6 and x is equals to 7, we can find the Poisson probability as shown in highlighted areas. So according to the table, the probability is 0.0425, and we can check this result using a technology, which is, for example, an Excel. So in Excel, we can find that the probability is 0.042484, and after rounding to 4 decimal places, the probability is 0.0425, which is the same value we found using the table. That would be all. Thank you.